Hey everyone, and welcome to this explainer. I am absolutely pumped to guide you through this whiteboard-style breakdown of the PyLadies Rivers Week 4 curriculum. Today, we are talking all about loops in Python. And hey, if you're a complete beginner with literally zero programming background, I want you to take a deep breath and relax. You are in exactly the right place. We're going to unpack everything visually, step by step, and by the end of this, you are going to feel incredibly empowered. Let's get started. So, to really understand where we're headed, we kind of have to look at where we've been. Last week, in week 3, you completely conquered decision-making. You figured out how to tell a computer what to do using if, elif, and else statements. That was all about logic, right? Making choices. But today, in week 4, we are giving your code a massive upgrade. We're moving into repetition. Instead of just making a single, one-off decision, we're going to learn how to make our programs do things automatically, over and over again, without you having to type out every single step. It's a real game changer. Okay, let's dive into this. Here is our roadmap for today. 1. Loops in real life. 2. The while loop. 3. For loops and range. 4. Controlling your loops. 5. Avoiding infinite loops. And 6. Our summary and a sneak peek at week 5. Section 1. Loops in real life. I want to reassure you right out of the gate, you actually already understand programming loops. You might not call it code, obviously, but your brain uses loops every single day. Think about brushing your teeth. You don't consciously tell yourself, brush tooth 1, okay, now brush tooth 2, brush tooth 3. No way. You just repeat one action, brushing, until a certain condition is met, like all your teeth feel clean, or maybe your 2-minute timer goes off. That right there is a loop. Or what about a washing machine? It runs a wash cycle repeatedly until the clothes are clean, and then it finally stops. Same thing when a teacher takes attendance. They just go down a list calling out one name at a time until the list is done. Or a cashier at the supermarket, repeating the same action. Scan, add price, next item. Scan, add price, next item, until the conveyor belt is totally empty. These everyday actions follow the exact same logic we use in Python. So, in all of those everyday examples, what we're really looking at is structured repetition. And honestly, it always boils down to just 2 fundamental rules. First, there's an action that repeats. Second, there's a condition that eventually stops it. That is literally it. When you start seeing loops as simply structured repetition, they completely stop feeling like some intimidating programming trick. We are literally just teaching a computer to do exactly what human beings naturally do anyway. With that real-world logic locked in, let's look at some actual Python vocabulary. Section 2, the while loop. And this brilliantly illustrates the concept. Think of it like a circular arrow. Instead of our code just running straight down from the top to the bottom and then finishing, the while loop literally tells Python to jump right back up and run a section of code all over again. It loops back on itself, repeating actions incredibly efficiently so you don't ever have to write the same line of code twice. So, how does it actually work? Well, a while loop repeats a block of code as long as a condition remains true. Let's think back to our washing machine analogy for a second. The machine handles an unknown quantity of dirt by acting while the clothes are still dirty. In actual code, if we write while count less than or equal to 5, the program is going to keep checking that condition. Is the count 5 or less? Yes? Okay, run the code. Is it still 5 or less? Yes? Run it again. It only stops when that condition finally becomes false. But what if we already know exactly how many times we need to repeat an action? That brings us to section 3. For loops and range. Now, what's really interesting here is contrasting these 2 loops. A while loop handles the unknown, like washing clothes until that clean condition is met. But a for loop handles a known sequence. It is exactly like that teacher taking attendance. The teacher already has the register in their hand, right? They know exactly how many students are on the list, and they simply step through them one by one. And the syntax for this in Python is just so elegant. Seriously, if you wanted to print the word hello 100 times, writing print hello on 100 separate lines would be an absolute nightmare. Instead, a for loop saves us. By just writing for I and range 5, we are telling Python to automatically repeat our action a specific number of times. The range function generates a sequence of numbers for our loop to walk through behind the scenes. Now, speaking of the range function, it actually has a bit of a hidden superpower. You can give it up to 3 numbers, for example, range 0, 10, 2. That third value, in this case a 3, represents the step. It controls exactly how much the loop counts up by each time. So instead of going 0, 1, 2, 3, it would step by 2, giving you 0, 2, 4, 6, 8. It's an absolutely fantastic way to control the exact rhythm of your repetition. Real quick, before we move on from the for loop, I want to briefly introduce a concept called nested loops. Now, I know that sounds complex, but it's really just a loop placed inside another loop. Just imagine drawing a grid. Your outer loop might count down the rows, while your inner loop counts across the columns. It's the perfect tool for building things like a multiplication table, which, by the way, is exactly what you'll be building in this week's assignment. But, sometimes while our loops are running smoothly, we suddenly need to change course.
And that brings us to section 4, controlling your loops.
So, the crucial point is that Python gives us two fantastic statements for controlling the flow: break and continue. Think of break as an emergency stop button. If you're looping through numbers 1 to 10 and you hit a break at 5, boom, the entire loop shuts down completely. It's over. On the other hand, continue is more like a skip button. If you use continue at the number 2, Python just skips the rest of that specific turn, completely ignores the number 2, and jumps right back to the top of the loop to process the number 3. So, break stops the write entirely, continue just skips a beat.
Section 5, avoiding infinite loops.
Okay, listen up, because this is the absolute golden rule of debugging loops. Always make sure your loop's condition will eventually become false. If you set up a while loop that says while count is less than 5, but you completely forget to write the code that actually adds to that count, like count plus 1, then guess what? The count just stays at 1 forever, and 1 is always going to be less than 5. Because the condition never ever becomes false, your code gets trapped. It runs over and over again into infinity, totally freezing your program. Always, always remember to update your conditions.
Let's move to section 6, summary and week 5.
Just look at everything you've accomplished today. You started by understanding that you already use structured repetition in your daily life. Then, you translated that into Python by mastering the condition-based while loop and the sequence-based for loop. You learned how to manipulate that repetition using range, break, and continue. And most importantly, you know exactly how to escape the dreaded infinite loop trap. You are now officially automating repetition in code, and that's huge. So you now have the power to make your code incredibly efficient and save yourself literally hours of typing. But right now, all your brilliant loops just live in one big script. What if you wanted to take that awesome loop you just wrote, wrap it up in a neat little package, give it a name, and reuse it anywhere you want without ever having to write it again? Well, are you ready to make your code totally reusable? Because that is exactly what we are going to do next. Get ready to organize your skills, and I will see you in week 5 for functions. Keep practicing those multiplication tables, and happy coding.